Thank you very much. Really quickly, thanks for inviting me. Thanks to you guys for coming out. A really quick overview of the talk. I'm hoping today, not to spend too much time convincing you that enterprise security currently sucks. It mostly does. What I want to talk about is a possible new way of addressing enterprise defense. And for the most part, what I'm trying to convince people is that we should be more comfortable with hackyness. Traditionally, people have looked down on it, and I'm saying that it's actually the most viable path for enterprise defense today. I'll talk a little bit about one of the free tools that we've released and mainly use it as a lens to view both successful enterprise defense and a hacky one. So we'll talk about that. And probably the biggest thing that I'm hoping for is to give you folks a bunch of links to a bunch of talks by people smarter than me. So even if my talk completely bombs, you should grab the slides because there'll be links to smarter people saying smarter things. I won't talk about my bio too much. The main point of it is I ended up spending about 7 years as a system engineer, about 10 years as a network attacker, looking for new ways to attack stuff, a small stint as a CISO, and now work as a product vendor. And the main reason I say it is to let you know that I've kind of got a pretty holistic view on what's breaking networks, how to break networks, and then some hope for realistically defending them. So one of the interesting things today is, if you look around, in some instances, we're not in as bad a situation as we were. So for a few $100s, you can buy products today that have a really good security posture. So from Apple, you're getting the latest iOS devices, and Natashenka straight after me is going to convince you otherwise. But you can buy hardware for a few $100s with really good security promises. If you saw Matt Miller talking, you'll see the range of mitigations and built-in SDLC changes that Microsoft has made over the years to kind of make sure that automated wormable attacks are a thing of the past. And this is a brave thing to be saying while the RDP zero-day hangs over everyone's head. But you'll see changes from Apple, changes from Microsoft, changes from Google. Google's Chrome team is ridiculous. Their Project Zero team is probably some of the world's best bug hunters. Their Chromebooks today, again, a few $100s, and you've got hardware-backed security that gives you pristine machines in a few seconds. And I guess what that means is we can all declare victory and go home. And obviously that's trite, and obviously that's not true. And instead of just taking my word for it, I'm going to do something that I often do, which is refer to quotes from these two people. So Brian Snow, for those of you who don't know him, was the Director of Information Assurance for the NSA. And he gave this talk at a conference in Malta. And his quote there was to tell everyone that, look, your systems continue to function and serve you, not because your guys are doing anything particularly special, but mainly because your opponents haven't chosen to take you out yet. And this is something that people in industry have been kind of turning a blind eye to for a really long time. If you caught Alex's talk this morning, a few years back, Alex gave a talk titled AppSec is Eating Security. And he started off by kind of splitting the Fortune 500 into two groups, where he said you kind of have a secure 100, which is a bunch of people who know how to do security, and then referred to the others as the toasted 400. Okay, and the interesting thing to ponder about this talk, there's a few things that are interesting here. The one is, for you to make it into the Fortune 500, your market cap is not something to be sneezed at. So these are not corporations that couldn't find money in the security budget. These are mega corps with billions of dollars at play, and Alex is referring to them as the toasted 400. And he's not even saying that the secure 100 are invulnerable to attack. He's saying they know how to play the security game. And with the toasted 400, they don't, and they probably don't know that they don't know. Okay, and without trusting any of them, you kind of have a reasonable existence proof. Different groups keep putting out different studies on the status of breaches and things like that. And if you go back to the 2015 M-Trends report, they'll tell you that most companies find out they've been hacked about 205 days after the original incursion. As recently as last year, Ponemon did a study, and that number is 197 days according to them. And if you ask me, those numbers are better than they are in the real world. Because in most cases, these guys actually talk about data that's self-identifying. So when you're talking about credit card data, for example, the credit card gets used at some point, and these organizations find out that they've been owned. And ignoring that, like, you turn on the news on any given day, and there's a new org that's been terribly broken. And what's interesting is you end up hearing the same sort of things. From the organization, of course, there's a press release that tells you that they really take security seriously and give you a link to free credit monitoring. But from our side, from the guys trying to defend networks, there's a few sayings that come out pretty consistently. Okay, and it's almost as predictable as the organization saying that they really care about our security. And the first one that you hear is that now management really needs to buy in, like management needs to take stuff security. And this may have been true before, but like it's just not true anymore. Like management has started caring about security for a long time. Like billions of dollars, hundreds of millions of dollars is being spent on security. There's a security conference going on almost every day of the year. So it's not just 100 people getting together. Like security has become big business. Like the RSA business hall overflows with people. And at some point, the Black Hat keynote looked like this. Like this was Mudge back in 99, walking in front of the screen to a small room. And today, the Black Hat keynote looks something like this, right? It's not true that management haven't enabled people. Lots of money is being given. In some instances, it's security teams who are now kind of skating by. Like management thinks they've done something, they invested this money, they built these teams, and they think that we've got answers, except for the most part, we don't have good ones. And the other thing that happens fairly recently whenever there's a break is you'll see a whole bunch of thought leaders on the internet scream about how the organization hasn't taken care of the basics. And people will scream like, now's the year we need to get back to basics. And it's super common. You'll see it all over the internet. It's what Twitter is made for, right? Like blah, 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 they didn't do password management. Like how stupid of them, they didn't do two-factor authentication. And of course, there's a ton of things wrong with this, but probably the easiest way to summarize it is there's a kind of survivorship bias playing out here, right? Like this is a mind map made by a guy called Rafiq Rahman who talks about all the things that a CISO needs to control. And of course, all of those things are basics. And what happens is when there's an attack that affects one of them, then someone goes, oh, they didn't take care of that basic. Okay, but of course there's a zillion of them and we're just picking on the one that happened to get someone owned. And the simple thing is that if it were simple, it would be done. Nobody is deliberately taking money and getting their networks compromised. So there are problems that need to be addressed. And the last one that I want to pick on from this sense is well, you know, what these companies need to do is to learn to think like an attacker. Like people just need to learn to think like an attacker. And this idea isn't new, right? Back in 93, Dan Farmer and Vitsa Venema released Satan. And Satan, the whole point of Satan was that you could start looking at your network with the eyes of an attacker. It spawned a $1 scanner industry as everyone starts to make scanners and add plugins. But the question is, I guess, 26 years later, what are we telling people to do now? This is Trend Micro advertising an upcoming thing for August 22nd, where they will teach you to think like an attacker. Okay, think like a hacker, and your network will be all okay. And of course, this doesn't work, right? Adam Shostak has actually written about this in the past, where he says, like, telling someone to think like an attacker is just not prescriptive enough. What Adam likens it to is expecting someone to be a whiz in the kitchen because you told them think like a chef. Okay, and it's something we forget. But if you step out of our comfort zone for a little bit, go into the kitchen, try thinking like a chef, and see how that works out for you. What's interesting is we thought about this a little bit, and there are definitely lessons that can be taken from offense. Okay, but what we think is that for the most part, people end up taking the wrong lessons. And we gave a talk about this a little while back at a conference called T2 in Helsinki, and I'll talk a little bit about this. Essentially, we believe that there are some things that offense was doing, and offense gets right almost accidentally. And one of the things we can do as defenders is start to isolate those things and focus on them. And one of the things that offense gets right accidentally, probably the biggest thing in my opinion, is offense naturally has very tight feedback loops. And you see this in a bunch of different ways, but probably the simplest way to put it is if you're a bad attacker, if you're an attacker and you suck, you know it. You know it really quickly. But you can suck as a defender for a really long time and not know that you suck. Okay, and this tight feedback loop allows people to sharpen their skills and focus on the right things. Dino Daizovi in the past gave a whole talk called Attacker Maths, or Attacker Math here in America, where he was talking about the importance of figuring out the cost of things, the cost of attacks. And it's something that attackers end up knowing intuitively, because when they're pulling off the attack, they know what it costs, they know the effort that goes into it, and it's something that defenders have to try to divine. And this feedback makes it really hard. And what it leads to is the fact that attackers are quick to throw away things that absolutely don't work. And defenders carry around this legacy for much longer than makes sense. And you see it with bad processes and bad policies in companies that end up being carried out that actually don't do anything. One of those that I want to focus on for this talk, and it's probably the bulk of this talk, is that attackers write code. Okay, and personally, I think this is not controversial, but recently Twitter proved me wrong. My central thesis here is that I almost never see good attackers who don't also code. Okay, and somebody else said this on Twitter and people lambasted him because they are awesome and they don't code. But I'm going to agree with the original tweeter here. I think coding is a superpower, and I've almost never seen a good attacker who doesn't. And again, this is fairly obvious, right? Like if you see any good attacking team, you'll see they patch their tools, you see them building tools. And again, it makes perfect sense, right? It's more than a decade since Mark Andreessen released his Software is Eating the World paper. And if software is eating all of these other industries, it makes obvious sense that software will be eating ours also. And you're starting to see this now when you take a look at really good defensive teams. So I've got a few examples here, and if you haven't seen these talks, they're really talks that I suggest you go check out. So on the top left, you have Nate Macaulay and Diego, and both of them were at Square when they did this really interesting talk about trust anchors. And the whole point of trust anchors, if you break it down simply, is in your organization having microservices that handle your valuable stuff. And the logic there was that you force an attacker to operate inside your premises. So an attacker doesn't get the ability to steal your data and view it offline. To view anything meaningful, he has to view it while inside of your organization. Next to him, you have Four, who gave this talk on Facebook. Again, a super interesting talk where he talks about how they got Facebook using two-factor authentication. And what's interesting about the talk is they end up using a combination of SSH patches, Duo's API, and the end result that they end up with allows people to authenticate faster using their two-factor solution than without it. So developers inside of Facebook apparently end up using the solution not because it's safer, but because it's quicker, and it also happens to be safer. The bottom two, you've got the folks at Netflix talking about their use of eBPF and how they use it to instrument all the things. Ryan Huber gave a similar talk using a competing framework, so they're using Audit D built into the kernel. And the really interesting thing about all these guys that's worth noting is that they're not traditional security teams just telling people what they can't do. They're security teams actually building the code that these organizations are running on. And we think it's a pretty big change. And if you go back to what Alex was saying, someone actually asked him, or it was part of his talk, that says, well, what differentiates the secure 100 from the toasted 400? And you'll notice central there is the ability to create and not buy solutions. Okay, so this ability to actually build stuff comes through. And once you build tools, the follow-on that comes from that is you start to build, unless you're completely terrible at it, you start to build infrastructure. Your tools start to build on top of each other. And again, this is all a veiled attempt to make you guys, you folks, watch my older talks. But way back in 2010, we gave a talk trying to convince people that their threat models were mostly wrong. And one of the things that we were saying at the time is, like, so this is 2010, it was pre-Snowden, it was pre a whole bunch of stuff, and you'd still see people talking about cyber war in terms of, well, Georgia was DOSed, like there was a large DOS attack against them. And what we were saying is, actually, if you look at good security teams, the thing to notice is that they build tool chains and they build infrastructure. And again, I'm not saying attackers do it because they're smarter. It kind of just happens as a natural consequence of writing tools and building them. And I gave a bad example at the time. So we were a pen testing company, and we built this one-off tool that extracted data from networks using timing. So across the internet, we've got command execution. We run this timing attack, and based on the time, we're able to extract data. And within a few months, we generalized it into a tool called Squeezer that could be used for SQL injection. And the joy of Squeezer using timing attacks is that we got it to the point where you could transfer binaries off a company's network just using timing attacks. And then right at the bottom, we introduced this new tool that allowed you to tunnel through company networks. So if you had just SQL injection or just some sort of attack against a web server, you could tunnel entire TCP conversations through those two compromised hosts to hosts on the network, just because we went from one time to Squeezer to this new tool called Reader. And again, the whole point is that this happens naturally for attackers. And if you remember the NSA leaks, or now the various NSA leaks that come out, they're not just a collection of zero-day, okay? Like, while people kind of focus on the zero-day, much more interesting is seeing the frameworks that they have sitting behind it. There's entire frameworks for exploitation and exfiltration, because again, that's what attackers do. Fortunately, both Nate and Diego pointed out during their talk that this is also what defenders do. Okay, and they pointed out that when they built their trust anchors inside of Square, you quickly start to see other opportunities to use them. Once you've built it, things just kind of naturally add on. And so I want to talk a little bit here. I want to start breaking into our Canary tokens. So Canary tokens is a completely free service. You go online to canarytokens.org. You're greeted by this, and something like more than 100,000 people have used Canary tokens and actively use it to figure out whether they've been compromised or not. And like in a USENIX first, I'm literally not standing up here to tell you about how clever the thing we built is. I'm actually expressly doing the opposite. I want to tell you how stupid the thing that we built is, but how it's useful anyway. And so if you go to canarytokens.org, you'll be greeted with this screen. And right at the top, I've selected the first type of Canary token, which is a web bug. And everybody's been using web bugs forever. You put in an email address to get your alert. And then you put down some sort of reminder that says, here's what I'm doing with this token. So in our case, I go USENIX demo desktop. We hit create. And essentially, what we get back is a URL. And the logic here is dead simple. When someone visits that URL, the system will mail that email address that reminder that we just put in. And so the logic is that you can sprinkle these things in a whole bunch of places. So in this case, we said it's on our desktop for USENIX. And when an attacker compromises your machine and finds this thing, clicks on it, they get back nothing of import, and you get back a message telling you, hey, listen, from this IP address with this browser, somebody just clicked on this link. Okay, at this point, you're not more complex than browsing your web server log file. Okay, completely straightforward. But already you'll see the first signs of almost fortuitous cleverness. So not something we intended to be clever, you accidentally get it right. And that's the fact that if someone's visiting you, you can already do more than just grab their IP address, right? So once they're visiting you, you can start geolocating their IP address. You can enumerate the plugins in their browser. If they've got a WebRTC leak, you can check what their real IP address is. Okay, and all of that because an attacker happened to click on your link. Okay, so it's pretty straightforward and again, pretty stupid. And in the light of really simple, the next token that I'm going to talk about is a DNS token. Okay, and this one again is super simple. We select the DNS token, we put in our email address, and we put in our reminder, which in this case says the USENIX demo for DNS. The system gives us back some sort of domain. And the logic here is that if an attacker ever looks up that domain, he gets back, she gets back some sort of response you don't care about, and you get back a notification telling you, hey, listen, someone's just looked up this DNS entry. Again, completely simple, completely straightforward. It's 100 lines of code or 2 lines of Perl. Yeah. But what's interesting is already this starts to give you options as a defender that don't exist otherwise. So how many of you are running Slack in your organizations? Quick show of hands. Okay, so enough of the audiences. One of the things that everyone's kind of worried about is what happens. So everybody focuses on what happens when Slack gets compromised, which is fair. But one of the things you should be worried about is what happens when someone in my org gets compromised. Because someone in your Slack channel searching for interesting keywords will generally turn up enough stuff out of context that'll be pretty bad for your organization. And right now, there's not a lot you can do to defend against it. And Canary tokens give you a really, even just the 2 super stupid tokens that we've saw, give you a simple way to tripwire this. So what you see here is I do a Slack search for the word hello. for months ago. I then go into that conversation and change where someone said, hello everyone, and instead I make the message, hey everyone, here's a link to top secret password vault in the organization. You drop it in and you forget about it. And the logic there is when someone in your organization gets compromised, the attacker is going to go into their Slack and search for top secret password vault or other stuff that you care about, find this link, click on this link, and you now know that somebody's searching around in your Slack for things that they shouldn't be. You can't buy anything to do this yet. And I don't think any of the big vendors, I can't see Symantec or McAfee caring about protecting your Slack. But if you've got people actively building stuff in your organization, and if you've got primitives that you can use, it becomes a natural consequence. And you can see other places you can shoehorn this in, right? You've got people running salesforce.com. Let's include a link that says export all data. You've got people running some sort of SaaS service. You can start tripwiring these things with tripwires that only get hit by malicious activity. And the whole point is that once you have those two simple primitives that say, let me know when someone views a link, or let me know when someone resolves a DNS name, you start to come up with a whole bunch of other tokens that are built on top of that. Okay, and I won't go through all of them, but of course the two super simple, obvious ones are you can start tokening Office documents or PDFs, right? So really simply, if someone goes to a site, goes to the token site, puts in their details for a Microsoft Word token, you end up with a Word doc. Again, pretty straightforward. Attacker finds this Word doc, which you can put anything in or name anything. The moment they click on it, it's going to come back and give you an alert. So in the background, this is fairly straightforward for anyone who's ever had to work with Word. Once you've got a primitive that says if someone resolves this DNS name or if someone visits this link, the question for you is just how can I make Word resolve a DNS name, or how can I make Word visit a link? And you'll know there's a ton of options, right? Embed a graphic into it, embed metadata into it, and we do a couple of these for you automatically. So the moment this doc is opened, it reports home and lets you know. Again, it's so simple, it can't really be effective, right? And of course, the reason I'm up here talking to you is because it is. Like even with this free Canary token service, we've got bunches of examples of people writing in and telling us, hey, we had no idea this was happening. We created all these Word docs, we strew them around outside of the web server route, and we found people actually reading them. We've got this one up on Twitter just because everything looks nicer when you realize that the Russians are attacking you. But again, this is an org that spends on security, has an active security team, and this free thing, let them know that there's much deeper rabbit hole that they need to worry about. And once you say, I can insert a remote URL in a Word doc, someone clever in the company says, well, hey, if we're inserting a URL, why don't we do more? Like, why don't we insert a macro into the document? And of course, once you've got a macro running on your attacker's machine, that macro can start to do more interesting stuff. So your macro can start getting the actual username, start seeing who registered the copy of Windows, or go as active as you want to. But again, all of these are really small jumps once you start off building something. And in the same way, you can start exploiting the quirks of the system you're operating on. So two cute quirks that we weren't aware of or weren't immediately aware of is that if you on a Windows network or if you're on a Windows machine, Windows still respects Windows.ini. Okay, so for those of you who have bad memories of Windows 3.1 or 3.11 sysadmining, those INI files still work. And one of the things allowed in the INI file is that you're allowed to set a desktop background. And one of the things about Windows is that you can set a desktop background to be a UNC path. Okay, so what you can do is take a canary token, that same vanilla URL, and set it as the desktop background. And now when an attacker browses that folder, his Windows will try to set his background to that UNC path, effectively telling you that somebody has just entered this directory. And you can start to get cuter because Windows allows you to sign binaries. They also need some way to enforce a CRL so that they can revoke those certificates. And that's just a URL that's going to get touched. So you can set a canary token as the binary is CRL. And now whenever someone runs that binary, you get a ping telling you that this binary has just run. Again, it's super cheap, it's super hacky, but ipconfig.exe or whoami on one of your production servers probably doesn't need to be run that often. It's probably a good indication that your system's been owned. And in this case, you drop the file, you forget about it, and when it runs, you get your notification that tells you that badness is happening. So the last token example that I'm actually going to give here is this one, which is you can also start exploiting SaaS platform quirks. So the AWS API key was an idea first spoken about by the security team at Atlassian. And effectively on the Canary token console, it's exactly the same. So super straightforward. You go in, you say, here's my email address, here's my reminder, and you say, create my token. And the system spits back a valid working AWS API key. And this API key is completely indistinguishable from any other API key that you might be using in your organization. And again, the logic is take it, put it on every desktop that you have, and when someone uses this API key, you get a message telling you the API key that you stored on your CFO's machine has just been accessed. Again, it's free IDS for all your desktops. It doesn't take a lot to drop down, but it's a really high quality signal that something's gone wrong on your CFO's machine. It doesn't matter how he's been compromised, and there's a zillion ways he could get compromised. What matters is that somebody's now tried to access AWS using a key that only your CFO had. So clearly something has gone wrong. Now, what's interesting about the AWS key is in the background, we've got an entire Rube Goldberg machine that generates that token. So a request goes off using AWS Lambda service. It creates something on a fake account. But what's important is that all of that becomes possible because we're just building on existing infrastructure, okay? And the stuff becomes trivial for you to integrate. So if you're out here and if you're looking at defending your network, there's two interesting reasons for why you want to do this. Lots of us here are researchers, right? And what you want is to build stuff that other people then build on. And what you'll see is, even with a simple framework like this, you'll start to see, so we've had Colin Mulliner, who I think has spoken here before, but has certainly spoken all around the world, and he's given a talk on how you can detect reverse engineering with tokens. Okay, so you take those same tokens, you embed them into binaries, and when an attacker is reversing these binaries, you get various stages of information. So A, they find the link. They have to check out that link to see what's at that endpoint. B, you wrap that link inside some sort of loop, and now you can tell if your attacker has managed to unwind that loop to decrypt this text. And for example, the guys at Cruise Automation have done an entire talk on how to deploy Canary tokens at scale. Okay, and they're talking about problems that we didn't even think about at the time. But what's interesting again is if you code and if you build these tools, they build infrastructure, and you start to see smart people building on top of them. And again, to take a step back for what we're actually looking for, you start to see real world results. Okay, so this is a guy called Shubs, and he's a pretty famous attacker. He milks bug bounties from lots of the big companies. And he points out that just the thought that the credentials he's picking up are not legit credentials or could give the game away start to make him step slower on networks. And that's kind of what we're in the game for. And the main thing to take away from this is that the world, the attack surface currently is too fluid, okay? And if you're sitting around waiting for solutions that the big vendors build, by the time they build it, things have moved on. And it's an inherent advantage that attackers have had till now, which is that they're lighter and they're more agile. And kind of the only way you get to that is if you're building your own stuff and building it quickly. And of course, the natural question that follows from this is someone saying, wait, so you're saying don't build anything, don't buy anything? And of course, that's not what I'm saying. For one reason, we now vendors, right? And for the most part, I'd love for you guys to buy stuff. But I think what it points to is a change in what we are buying. Okay, so I think in an old throwback to the Unix philosophy, instead of looking for these single monolith solutions like Symantec or McAfee are going to provide and fix everything, what you're looking for is smaller solutions that effectively take in input, spit out output, so that your teams can chain them together and start getting meaningful results and start driving them as they want to. Fundamentally, we can't be expecting to buy products and as a substitute for thinking. And one of the fundamental things, if we go back to the topic of making things and embracing hackiness, is to avoid letting perfect become the enemy of good when we're defending networks. And you'll notice that attackers don't do this. So for years, we used to give people training on how to break into networks. And one of the things you start doing from day one is telling people, yes, your tool is not perfect. Like you get a reverse shell, and your shell doesn't echo the stuff you're typing. Yeah, that's not how that shell was intended to be used. Go on and own the system. You're doing something and it works in some quirky way. You, as an attacker, you expect imperfection and you work around it. And as defenders, for some reason, we've started to obsess over perfect. And there's tons of solutions that were really good that get killed on the vine because they weren't perfect. Way back in 2003, the guys from Indiana University released a tool called Sebek. And Sebek essentially would monitor all of your keystrokes, all of your syscalls on an operating system so that you could build honeypots with them. And Sebek was totally neat. And almost a year later, someone gave a talk at like CanSec West or Black Hat on how to detect Sebek. And the attack was really smart. It used timing differences. So you'd issue a command and see how long the OS took to execute it, and you could tell that Sebek was running. And so from that point on, people stopped using Sebek because, hey, it's detectable. And that's 2003, okay? And I guarantee you, if Sebek was still running when Snowden was running around owning random hosts by jumping on open shares on Windows machines, we'd have a better idea of what he was doing. Just because if it was defeated in the lab and defeated at a Black Hat talk didn't make it useless, and it shouldn't have been thrown away. We don't have to be perfect as defenders. We don't even have to win every battle. Okay, something that often comes up with Canarytokens is someone says, well, how do you get super wide deployment? Like, what if you miss something? And the answer is you're missing something now. Like you're missing everything now. Put these down and have a shot. Like you don't need tripwires to have 100% coverage. You want them to make someone really nervous about stepping around in your stuff. And occasionally you'll get super lucky and you'll find out things that you didn't know. In fact, this sort of thinking turns around the paradigm, because for years everyone used to say that attackers only have to win once and defenders have to win all the time. But if you start thinking like this, you start to figure out that actually an attacker can win everywhere, and as a defender, you just have to find them once. And if one of those places is where you find them, you can start rolling incident response and start containing them and getting them out of your network. And if it's stupid and works, then it's not stupid. I kind of want to force, especially this crowd, to start thinking about building products. And as an extension of that, building companies that build products. Like, everyone knows that the security product industry has sucked for a long time, and it sells half-made solutions with bad UXs that suck, that don't really do what they're supposed to. And then we just go back to doing other stuff. And almost what you need to do is throw your hat in the ring and start being the change you want to see. If you do have an enterprise that you're trying to defend, one of the natural defenses here is, okay, it's cool for Square or Google or Apple to have security teams that do defense like that, but we smaller and we can't. And the easy answer to that is what you're doing now doesn't work either. Like, at least we should try something different, because at least it's got some hope for actually working out. So for the most part, I'm saying what we should be doing is getting used to solutions that are quick, dirty, and hacky. They at least give us a shot. That's all that I've got. You can scream at me on Twitter. I'm at Haroon Meer. Or I think we've got time for other questions, and there should be a mic going around. Thank you very much for your time.
All right. Thanks, Haroon. You can scream at him with the mic right now if you're interested. We have a few minutes for questions. All right. Shied, you want to walk towards the mic over there?
Hey, Haroon, nice talk.
Thanks.
I have a very simple question. So you are actually banking on using documents or other links that could help you, tokenize the attacker. But if we see it from the attacker's perspective, and the recent IoT botnets that have been flourishing, they do not actually care about getting information from your machine. Rather, they want to just grab your machine and use all of those in a distributed fashion to attack another destined device.
Right.
So how can using these Canarytokens be helpful in this case?
Right. So the first answer is nothing you're going to use is going to defend you against every attack. Like, if someone's attacking you and doesn't plan to use the data on your network, tripwiring your data is not going to help you. So mostly it comes down to knowing what you're likely to be attacked for and making sure that you're protecting that stuff. So as a company, what we build, like Dev mentioned, is honeypots that detect when they're being attacked. And our honeypots can, for example, emulate SCADA systems or IoT systems, but it's a different problem. And so for the most part, I think one of the reasons why hacky defenses work is because you look at what it is you're trying to protect against and build solutions to do that, instead of just using generic security solutions that probably don't address your needs.
The other question, so when you say that, okay, think from the attacker's point of view, but knowing what the attacker is going to do with my machine is an NP-hard problem, isn't it?
So I think there's, so it's a good question. And I think the easy answer is that there are things that, so you can't predict that someone's going to use all the desktops in your organization for DDoS reflection. The question is if that's the thing that keeps you up at night. So I can tell you, on our company, if somebody used us for a DOS attack, I think it's a bad Monday. But if someone were to read customer information that we have, it would ruin my company. And so the thing that keeps me up at night is knowing when someone's doing the latter, not the former. And you've got to figure out what matters for you. If you're an IoT manufacturer, absolutely you should be thinking about the lawsuit you're going to get when every one of your devices becomes an amplifier in a DDoS attack. For the average organization, I'm not sure that should be what keeps them up.
Thank you.
Thank you.
Any more questions? I'll ask one quickly. You said many things that are putting me in this sort of logical bind. One, attackers learn quickly, but then like let's not overthink and let's not let perfect be the enemy of good. But like attackers will learn and browse Windows with an internet disconnected machine and like disable desktops, wallpapers, and turn off the internet.
Right.
How, like 5 years from now, do you think these hacky defense solutions are gonna still be around? Because like
Yeah.
PhD lifetime is 5 years.
Yeah. It's a super good question, and I think I have multiple answers for it. So rephrase the question is, well, you're going to start an arms race, and the one part of that answer is right now you're just losing the arms race. Like get into the race, and so one part is that. The other part is, even if attackers have to totally change what they're doing, right now it's so easy that they don't have to. Like let's start that. Let's make that bit harder. And the part like good security teams, your team, like good security teams know that you kind of have this co-evolution that happens, and attackers up their game and defenders up their game, and I think the top security teams have known this and operate this way. And the problem that we have is that entry-level teams or teams that aren't as well resourced think that they can avoid that game. And mainly I'm saying that I don't think they can. They've got to get in that game too.
All right, let's thank Haroon once more.
Thank you very much.